Hello Year 9, in this video we're looking at this question 11 which says a true bearing is 80 degrees. Write an expression for the true bearing of the opposite direction of 80 degrees if A is between 0 and 180 and then if A is between 180 and 360. So this is quite a difficult question because we're not given the value of 80 degrees. We're simply given two possible options, either A is between 0 and 180 or A is between 180 and 360. And so we have to think in generic terms, and if you're quite new to bearings, that can be a difficult thing to do. So what I'll do to start is we'll begin with part A and we'll draw 2 points, because remember, a bearing is a way to measure the direction of travel. So that means we must be moving from one point to another. So I'm going to draw 2 points. I'll just call them point X and point Y. And let's assume that in our original case we're moving from X towards Y, so we're moving in that direction of travel. And the first thing to note with true bearings is that you need to overlay a compass on one of the points, and the point where you draw the compass is the point where the travel begins. So in this case, if we're starting at point X, that is where we should overlay our compass. So I'll do that here. And here we have north. And a true bearing is always measured from north in a clockwise direction. So I'm going to start at north and move in a clockwise direction until I hit the line representing our travel. And so what we're told is that that true bearing is 80 degrees. So I'll write 80 degrees in here. Now the question is asking us to consider the true bearing of the opposite direction of 80 degrees. And what that means is instead of moving from X towards Y, we're reversing that direction of travel and we're going to move from Y towards X. So if I want that true bearing, I need to overlay my compass at point Y. So we'll say this is north. And what I'm interested in is what is the angle starting at north, going in a clockwise direction all the way around to the line of travel. So notice that's a much larger angle. And if our original angle here, our original bearing was A, what we are wondering is what must this bearing be in the opposite direction of travel. And what can help us is to notice that given we have drawn two compasses here, by definition, the horizontal components of these compasses must be parallel, moving from east to west. They must be parallel lines. And that means these two angles here, this angle and this angle, must be equal because they are alternate angles on parallel lines. So if I can find out what this angle that I'm indicating in red here, if I know what that is, if I can know that in terms of 80 degrees, that can help me work out this new true bearing. And in particular, it helps because I know this part is 90, and I know this part is 90, and I know this part is 90. So all I need is this final part, and I've got everything I need to put the true bearing together. So if we go to our original bearing, the whole bearing from north to the line, that whole bearing is defined as 80 degrees. And I can think of this little extra bit as being the whole angle 80 degrees minus this 90 portion here. So I can think of that as A minus 90 degrees, which means this extra portion here is also A minus 90 degrees because they're alternate angles on parallel lines. So that's all I need to put the bearing together. That means the new bearing must be 80 degrees minus 90 degrees plus the 3 sets of 90 degrees that are already there. And the first minus 90 will cancel with the first plus 90, and we're left with 80 degrees plus 180 degrees. So that's an interesting result. That means if I've got some true bearing A, where A is doesn't go beyond a straight line, it's between 0 and 180, then if I reverse the direction of travel, all I need to do to find the true bearing in the opposite direction is to add 180 degrees. So that's somewhat interesting. If we now think about part B, now it's the same question, but we've got a different assumption for our original bearing. It's going to be between 180 and 360. So to draw that diagram, I'll still have 2 points, a point X and a point Y, but I'll draw them in a different orientation just so that I can see that my original bearing will be above 180 degrees. So if I'm moving from X over to Y in that direction, then I will draw my compass at point X because that's where my travel is beginning. So here's my overlaid compass. This will be north. And now the original bearing will go from north in a clockwise direction, and that is defined as A degrees. And just like last time, if we reverse the direction of travel so that we're going now from Y towards X, then I will overlay a compass at Y. So this will be north. And the new true bearing that we care about is from north over to the line. So that's now the diagram we're dealing with. Notice that the original bearing is more than 180 degrees as a result of the way I've drawn the diagram. And so again, if we know this whole angle is A, what must this angle be to get our new true bearing? And once again, knowing just this part of the original bearing will help us a lot because, again, these compasses must be parallel, the horizontal components and the vertical components, but most usefully the horizontal components are parallel. That means this angle I've indicated in red here is equal to this angle here because they're alternate angles on parallel lines, and that just happens to be the exact true bearing that we're looking for. So if the whole angle of the original true bearing was defined as A, then this bit in red must be the whole angle A minus 180 degrees because we've got two 90-degree components. It's a straight line, and a straight line is 180 degrees. So this extra bit is A minus 180 degrees, which means this new bearing is also A minus 180 degrees. So that's all we need to write our answer. The new true bearing is A degrees minus 180 degrees. And you may find that equally interesting because for part A, when we had a true bearing of A, the true bearing in the opposite direction was A plus 180. Now, in the same situation, which is simply with A being more than 180 degrees, the true bearing in the opposite direction is A minus 180 degrees. So that's kind of like there's a symmetry there to those answers, which is somewhat interesting. So that's basically how you tackle that question. Hopefully you were able to follow along there. I am conscious that bearings can be quite difficult when you're first learning them because there is a lot of terminology and a lot of new language. And it's helpful to remember, to always remind yourself that bearings are simply a more precise way to indicate direction. And so hopefully once you practice them enough and get comfortable with the new elements of the language, they're kind of within your grasp and they're not too difficult to tackle. This question in particular I think is quite a tricky one for someone new to bearings simply because we don't have a value for A degrees. We have to tackle this in purely generic terms, and it can be quite hard to know where to begin. So I think the key takeaways from this question are to always remember that when we're dealing with true bearings, you always draw a compass at the point where the travel begins, and you record the bearing as going from north all the way over to the line moving in a clockwise direction. And I think if you remember that key point, that should hopefully stop you from making any errors when tackling these kinds of questions. All right, hopefully you followed along with all that and found that helpful, and tick boom.